Hey guys, this is the notes for 7.1. So this is a new section. It deals with similarity. Sorry, this is a new topic, similarity. And the first section is dilations. So this is 7.1. So a dilation is a proportional enlargement or reduction of a figure through a point called the center of dilation. So this is actually our last transformation we're going to go through, but this isn't a rigid one because the size changes. Okay, so when dilated, the angles of the pre-image and the new image are congruent. So the angles do not change. Okay, now the side lengths do change, but they are proportional. So the side lengths of the pre-image and new image are proportional. All right. Now, if we look at the size of the enlargement or reduction, this has a certain name, and this is called the scale factor. Now, if the scale factor is greater than 1, so larger than 1, then it's going to be an enlargement. So the shape is going to get bigger. Right? If it's less than 1, so between 0 and 1, then the dilation is going to be a reduction or get smaller. So this would be like 1/2 or 1/4 or something like that. Now, if the scale factor is equal to 1, then the original figure and its image are going to be congruent, right? They're not going to change size. So technically, we really don't even have a dilation if it's equal to 1. Okay, and some important note I wrote was when dilating a figure on the coordinate plane, we focus on the coordinates. When enlarging or reducing a figure, you multiply the coordinates by the scale factor. Okay, so we'll see that in this next example. It says dilate the figure using a scale factor of 2. So we're going to look at the original point, okay, A, B, C, and D. So we can plot them. Right, A is at 1, 2. Here's A. B is at 0, 2. Here's B. C is at -2, 1. And D is at -2, -1. Okay, so this is our original image or our pre-image. Now we're going to use the scale factor to draw our new image after a dilation. So scale factor of 2 means we multiply everything by 2. Okay, so A prime becomes 2, 4 because it's 1 times 2 and 2 times 2. C prime becomes -4, 2. B prime becomes 0 times 2 is 0. 2 times 2 is 4. And D prime, -2 times 2 is -4. And -1 times 2 is -2. Then let's just plot them. So we have 2 and then 4. Here's our A prime. B prime is at 0, 4. C prime is at -4, 2. And then D prime is at -4, -2. So we had an enlargement of 2, and this is our new figure on our coordinate plane. Now what we're going to do is analyze dilations, okay? So the first step to analyzing dilations are looking at their angles, right? Their angles should be congruent. And if we look at them, A and A prime, right, B and B prime, C and C prime, and D prime are all 90-degree angles. Therefore, all angles are congruent. Okay, now we're going to compare the side lengths. Okay, so let's look at first AB. AB is 1, 2, 3, right? You can see that's a length of 3. Then we can do BC is 2, right? 1, 2. CD is 3, and AD is 2. Right? And now we're going to compare them with now their primes, right? A to B prime is 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Now B to C prime, B prime to C prime is 1, 2, 3, 4, 5, 6. Right, and this is going to be 6, and this is going to be 9. Okay, now we're going to find the ratios of all the corresponding side lengths. Okay, so right, the A and B corresponds with A prime B prime. Okay, so let's make the ratio. So let's make the primes first. Right, so new over pre. Right, so the new distance would be 9 over the pre distance 3. Right, which reduces to 3. This one, the new is 6 over 2, which reduces to 3. 9 over 3 again, which is 3. And then 6 over 2, which is 3. Okay. So, right, all ratios are equal to 3. So, the sides are proportional. Right, and like we said in our definition of dilations, right, all angles are congruent and all sides are proportional. Now, on your own, I want you to try number 2, okay? Similar to what we just did in example 2, right? It says, how are the side lengths and angle measures of the two figures related? So I want you to look at their angles and then prove that their sides are proportional. So angles need to be congruent, sides need to be proportional. So I want you to prove that for number 2. So I'm going to have you pause this and then I'll show you the solution. All right, so hopefully you tried number 2. Here's the solution, right? We can see the angles are all 90-degree angles, so they're congruent. And then all sides are proportional because, right, we can see they're all, right, some of them are 6 to 2, which reduces to 3. And then some of them are 3 over 1, which reduces to 3. If they all have a ratio of 3, then 3 to 1, right, then they're proportional. Now, in example 3, what we want to do is we want to find the scale factor. Right, so to do this, we're going to pick out one length in its proportional side and then set up a ratio. So, right, we're given it's a dilation, so they are proportional, right? So what I'll pick is I'll pick K prime L prime and set up a ratio with K to L. Okay. That's because I'm given these lengths right here, all right, so I can set up a proportion. So K prime L prime is 18 and K to L is 12. So let's reduce this. We get a a ratio of 3 over 2. Therefore, my scale factor is equal to 3 over 2. All right. So now I'm going to have you pause this, and I want you to try number 3, and then I'll write down the solution for you. So pause this, try number 3. Okay, so hopefully you tried number 3. I'm going to quickly go through it. So is this an enlargement or a reduction? Well, our new image is smaller, so it's a reduction, right? And then one of the sides we can easily compare is AC, right? And A prime, C prime. Right, we can count. The distance for A prime, C prime is 2. The distance for AC is 1, 2, 3, 4. Therefore, our scale factor is 1/2. Right, and that makes sense, right? If it's a reduction, it's between 0 and 1. All right, so now we're going to use a coordinate grid, and we're going to do a dilation of PQR about the origin. So this was like before earlier when we were given the points, and we just use the dilation given. Okay, so our P, we can see, is at 8,4. Q is at 12, -4. And R is at -4, 0. We're doing a dilation of 1/2. So our scale, 1/4. Our scale factor is 1/4. So we multiply by 1/4 to the X and Y's. Okay. Now for our P prime, we're going to get 8 times a fourth is 2. 4 times a fourth is 1. Q prime, right? 12 times a fourth is 3. And -4 times a fourth is -1. And then R prime, -4 times a fourth is -1. And 0 times a fourth is 0. All right, so then we can draw these 2, 1. It's right here. So here's P prime. Q prime is 3, -1. And then R prime is -1, 0. And here's our new image. Now it says, how are the distances to the origin from each point related to the distance to the origin from each corresponding pre-image point? Well, we did a dilation of 1/4 about the origin. That means it's the fourth of a distance away from the origin as the pre-image. Okay, so fourth of a distance from origin, then pre-image. All right. Now, next, we're going to go over a problem where it does not have a center at the origin. When we're given a problem of a dilation from a point, right? So this says dilation of 1/2 at point R. Okay. So the dilation is centered at R, which is -2.7 with a scale factor of 1/2. Right, so each image is at half the distance from R as the corresponding pre-image point is. Right, sort of like before, it was a fourth of the different distance from the origin. Well, this is a half the distance from point R because we're doing a dilation about point R. All right, so for each pre-image point, we're going to multiply the horizontal and vertical distances from R by a half. Then add the distance to the coordinates of the center of dilation. Okay, so Q, right? We want to find the distance from R. Well, horizontally, right? They both are at -2 on the X, so the distance is 0. Vertically, this is at -1. Well, the distance from -1 to 7 is going to be 8. Or sorry, -8. Right, because it's 7 and then it's at -1, so it's down 8. Right, now we're going to do it for S. Right, This is at 4, so we're going to the right 6. And then it has the same y value, so there is no vertical. Now horizontally, -2 to 4 again is right 6. And then 7 to -1 is down 8. Now we need to multiply these horizontal and vertical distances from R that we just found by 1/2 because our dilation is 1/2, right? So now 0 times 1/2 is 0. Now -8 times 1/2 is -4. 6 times 1/2 is 3. 0 times 1/2 is 0. 6 times 1/2 is 3. And then -8 times 1/2 is -4. Okay, so now what we need to do is add these new distances we just found, right? The half distances from R to our original R coordinate. Okay, so to do that, what we're going to do is we're going to do, right, our -2 from R plus 0, because it horizontal is 0, and then 7 minus 4, right, because we're going -4 vertically. -2 plus 3, because we're going to the right 3, and then 7 plus 0. And then -2 from our R again, plus 3, and then 7 minus 4. This will give us our final image point for Q prime, S prime, and T prime. Right, R prime's not going to change. R and R prime aren't going to change. They're going to be the same thing because they're dilating at R. Okay, so our new point here is at -2, 3. New point here is at 1, 7. And new point here is at 1, 3. Right, so this is Q prime, this is S prime, and this is T prime. All right, so now we can just graph them. All right, we know R prime stays the same. R prime. Q prime is at -2, 3. Here's Q prime. All right, S prime is at 1, 7. And then 1, 3 for T prime. And here is our new image dilated by 1/2 at point R. Now, what I want you to do is try number 5 on your own. I want you to find the center of dilation for this, and then what is the scale factor. Okay, so you're going to work a little opposite. Right? You're actually given the new image and the pre-image. You want to find the center of dilation, right? So you should look for the point that's not moving, right? And then figure out the scale factor, right? What changed from the distance from that center of dilation point. All right, and then pause this, try number 5, and then I'll show you the solution. All right, so our center of dilation has to be A because that point hasn't changed from the new image and the pre-image, right? Then we need to figure out what is the scale factor, right? What is the scale factor? What's the distance from A for C, right? And what is the distance from A to C prime? You could have picked B and B prime. I just showed C, right? So the horizontal and vertical distance away for C was 4 and 4 from that original A point. And then C prime is 6 and 6, right? So we need to set up a ratio right here of C prime over C, right? So 6 over 4 becomes a scale factor of 3 over 2 when reduced. If you have any questions, let me know on Remind or Google Classroom.